Going to talk about verifying identities in this video, and my suggestion would be to pause, go ahead and get out a sheet of paper, take some notes over this section and some of these things that I'm going to point out to you, and write down these examples, because that way at least you've got two somewhere that you can refer back to as you're doing your work. So I'll wait for you to do that. One thing I will tell you about verifying that is perhaps a little better than simplifying is that you know the end result. You know where you're trying to get to. And with simplifying, sometimes you don't know when you're finished. Who's to say it's as simplified as it can be when you're not really sure what the goal is? So one good thing about verifying is you do know what the goal is, and you can still do the same kind of process that you use when you're simplifying, but yet you know when to stop. You know when you're done. All right, so you can already tell that this is set up differently in that we are dealing with an expression that it is equal to equal to something. One, it's not going to be equal to 0, but it's equal to 1, or it's equal to something else. All right, we've got another example down here that we're going to look at, and you can see that it has two sides and two different things there. So anyway, all right, so what I would do is jot down a few of these techniques. And the number one thing is that we only want to work with one side of an identity at a time. When we start this process, we commit to one side, we finish it, and we stick to that side during the whole process. Some people like to try to do two things at once and tackle both sides at the same time, but that's not how we're supposed to work on this. The goal is to transform one side to be the other. Okay, so the next thing would be to start with the side that appears to be the most complex. The one that looks like you can do the most simplifying with it. Sometimes it's kind of hard to decide which one will be more complex or which one you can actually make something happen with. And that's when you may have to go back and start over if you realize it's not going well. Also, what you're going to do is just use your trig identities and do things that you've already been doing, like rewrite the expression in terms of sine and cosine, or look for something that could factor out or something that will cancel. And then the big thing that you're probably going to encounter is the need to get a common denominator, especially when fractions are introduced into the problem. So that has already happened on some of these simplifying questions. I know that I did do a video over one of those, so if you need a refresher, go back and watch that. All right, but without further ado, we will go ahead and we will start tackling this question. I just looked up two old problems that I had on an assignment, so that is the reason those were called number 1, and then skipped to number 7 mysteriously. So, all right. On this first question right here, we want to transform one side to equal the other. And you can see that it's telling me that the entire left-hand side of this equation should equal 1. So it's like saying, hey, if you simplify this, you're going to get 1. So that's our goal. We want to transform it to be that. All right, so when you look at this left-hand side, I definitely see a lot that can go on right here. Not really sure what I'm going to do with the cosine squared yet, but I do know that I can go ahead and look at these three expressions that are multiplied together and get something done with those. So let's turn everything to sines and cosines, and these are implied that they're multiplied together, right? So sine and cosine is good. Tangent, what can you change that to? Sine over a cosine. Good job. So there's that. And we're going to stick with this and clean it up. I know there's a plus cosine squared over here. I'm going to write it down just for formality's sake, but I'm definitely focusing right now on getting this cleaned up right here. All right, so what do you notice happens? What you notice happens is that we've got three expressions that are multiplied. This cosine cancels with that cosine. Well, that's nice, because all we have left now of those three things that are multiplied together are two sines. So we'll make that a sine squared plus a cosine squared. And now there should be something going off in your brain, like some kind of blue light, some sort of math siren telling you, oh my goodness, I think I know what that is. All right, look on your identity sheet for Pythagorean identities. Sine squared plus cosine squared, that is a straight up Pythagorean identity. it is equal to 1. So see how I didn't do anything to this right-hand side of the equation. I literally just brought it down every time. And then I get here at the end, that 1 is equal to 1. So I verified that that identity, when simplified, is a 1. All right, so it's pretty much the same thing you've been doing. It is just a little bit different sometimes when you're dealing with the one that's a little bit harder. And so this question right here that we're about to go over, this is really the goal problem for a verifying identity question. It is one of the ones for sure that I like to say, hey, you need to be able to do that. All right. There are ways to approach this problem from both sides. It depends on how you look at it as to which way you're going to approach. All right. So what I'm going to do is show you the way that most people will go about doing this. And that is to start with the right-hand side. The reason why is because it is an expression that's subtracted. And most of the time, that means I can somehow get a common denominator and I'm going to get two fractions together. And then there's going to be some simplification that can occur. So that is my thought process there. I can probably combine two things to make one expression, which is what I need to do anyway. So sometimes it's easier to combine than it is to expand. So that's why I'm going to start on the right-hand side. Okay. All right. So if we're doing that, then I probably would change cosecant to 1 over sine. Getting things in terms of sines and cosines tends to be the surefire way to make something happen. All right. Cosine and cotangent are along for the ride. Bring them down, okay? Now, over here on the right-hand side, we got to take care of some business because there are two fractions. We need a common denominator. All right, so how can I make this fraction have a sign on the denominator? Multiply it by sign on top and bottom. So that's what we're going to do. This should look very familiar. It is just like a video that I showed you, like the problem Mr. Brown came in and showed you as well. All right, so we get that going. Bring down this first fraction. We're not touching it, but in this box here, we're simplifying this. That's a sine squared now over a sine. Now, don't get crazy. Don't start combining stuff. We're not trying to simplify this fraction. We're trying to get these two fractions together. That is when we got a common denominator. All right, so if you combine these, sine is your denominator. It is common now. And on the numerator, it's 1 minus sine squared. Okay, and again, you're just bringing this right here is along for the ride. I'm literally just going to draw an arrow because it's not changing. I just know what I'm trying to get. Okay, we're still trying to get a cosine times a cotangent out of this stuff, and we're almost there. Okay, so what you need to do now is see that there's something going on the top of this fraction you've seen before, and it is a version of that Pythagorean identity. So again, the sine squared plus cosine squared equals 1 identity is a very, very commonly used one. You can see we want to somehow transform this to say 1 minus sine squared. Well, if I just get creative and take that sine squared over there by subtracting it from both sides of the equation, which is what I'm doing. I just don't always write that. All right. So look, I've got cosine squared is equal to that expression I have. So guess what I'm going to do? I'm going to replace the expression 1 minus sine squared with just a cosine squared, which is great because now we're making some progress. All right, now believe it or not, it's there. All right, the thing that you want is there. I see the cosine, I see a cosine squared, and I see we need a cotangent. So something is, it's there, but it's hidden. So I want to show you one way you can look at this, okay? Cosine squared means cosine times cosine. You agree with that? All right. And we still have a sine on the bottom. Now, it doesn't matter how you view it. All right. I'm running out of space, which is kind of a tragedy here. I can look at this cosine being the solitary cosine. All right. I could break this fraction up. You don't really have to, but we could break it up like this. All right, is that not still the same thing I had above, but I just broke that fraction up? The only reason I'm doing that is so you can see the leap that I'm about to make, all right? When I get here, I can see that I have a cosine. This is really bad. I shouldn't have let this run over, but I'm going to have to. All right, and what is cosine divided by sine? Oh, I just wrote on my problem. It's cotangent. That's right. Okay, so look, I'm there. technically, if I had not taken up so much space, I would be able to, here at the very bottom, write that cosine is equal to cotangent, but I missed. Alas, I ran out of space. All right, so when you get to a little place like this and you're trying to figure out how is what I want in the midst of this, one thing you can do is just pull apart those square terms, because technically, remember, it's just two of those multiplied together. And I'm totally okay if you went from this step that I'm hovering over right now to the last one. I mean, you don't have to show this step right here. It's good because it really breaks it apart. If you were trying to explain it to a friend, they probably would really like to see that pull apart step there. But I mean, I'm okay with you going from here right over to this last step because it's there. I can see it and I would know what you meant if you did that. All right. I know this is tough, but y'all are smart. That's why you can handle it. And I'll try to be checking in with y'all and helping you, and just hang in there. Okay.